Hello, welcome back to my channel. Today we're going to discuss the exact differential equations, and it is different from the methods we've already discussed. For example, variable separable, reducible to variable separable, homogeneous differential equations. So it basically involves a few concepts of partial differentiation. So first of all, this video is going to be just the introductory aspects of exact differential equations. So let's discuss the format. Or say a differential equation is in this form: mxy dx plus minus nxy dy. It is said to be an exact differential equation if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. If this criterion is met, the, the equation is said to be an exact equation. So yes. Now we're going to discuss if an equation is said to be exact, then what are the required aspects? Number one, once we have found that the equation is exact, check for exactness criterion, which is this one. And secondly, once it is proved that an equation is exact, then we find the integration of function of m with respect to dx yields some sort of answer, but in this equation y is dealt as constant. Number three, we're going to find integral of n xy with respect to dy. But the criterion that's supposed to be kept in mind is that these terms should be terms free of x. Terms it is supposed to be well kept in mind, because when we are going to integrate the n term with respect to dy, we are not supposed to include the x terms. So in the end, let me write the answer in the full way. So the solution shall be of this form: m x y dx plus n x y dy is equal to c. This is what we are going to follow on into the answer of our differential equations. So now we're going to have a bit of insight of partial differentiation. Basically, it is represented by this form. Here comes an dependent variable, here comes a dependent variable, and here comes a dependent independent, and here's the sorry, my bad. Here is the independent term, and here's the dependent term. While same is the case in case of differentiation, dependent over dependent, independent. So basically, the thing is, the concept is pretty different. When we are integrating some function with respect to dx, in this case, only x is operated, y is dealt a constant. Okay. Similarly, in the case where we have df over dy, in this case, x is dealt as independent. Uh, I mean, it is a constant, by the way. Sorry for the misuse of the terminology. It is a constant, and y is in fact y is operated. So that's all for a bit of touch of exact differential equations and partial differentiation. Just a bit of touch. In the next video, we're going to solve a few questions related to partial differentiation. Until then, see you in the next video.